This example asks us to evaluate the indefinite integral of secant of x dx. And this question is going to require that we do some algebraic manipulation as well as u substitution. So I'm going to start off with my original indefinite integral, and we're going to multiply secant of x with a fancy version of the number 1. So I can only multiply by 1 because otherwise I would change the value of my integrand. But the fancy form of 1 that I'm going to multiply by is secant of x plus tangent of x over secant of x plus tangent of x. And then we don't want to forget our dx at the end. Now I'm going to go ahead and use u substitution. And because we've introduced this new fraction, I'm going to set u equal to secant of x plus tangent of x. And what happens is, if I find du, I know that the derivative of secant of x is secant of x times tangent of x. And the derivative of tangent is secant squared x. And then we have this dx here at the end. And so what ends up happening is I have my u value here, and that's appearing here in my denominator. So that's where we can find that. And then if I were to distribute secant into these two terms, I would end up getting secant squared x plus secant of x times tangent of x. And notice that that boxed expression there is exactly our value for du. Okay, so now I'm going to go ahead and rewrite my integral. So I have the indefinite integral of 1 over u du. And I know that the antiderivative of that is the natural log of the absolute value of u plus our constant of integration. And then lastly, we can go ahead and substitute in so that we can get our final answer back in terms of x. So we have the natural log of the absolute value of secant of x plus tangent of x plus our constant of integration. And this is our final answer.